Welcome to the Google Cloud Platform Education Series. My name is Jeff Davis, and in this session, we'll discuss adding machine learning into your applications. We'll be running a moderated Q&A during the session, so feel free to ask questions using the Ask Your Question field at the bottom of your screen. Let's get started. We'll begin by doing a series of demos. We'll show the capabilities of Google's machine learning APIs, and we'll show how you can access those through simple web interfaces or through incorporating them using client libraries in your own applications. Then we'll move on and talk about machine learning as a whole on the Google Cloud Platform. We'll talk about use of the APIs and their capabilities and pricing. We'll also talk about Google Cloud Machine Learning Engine, which is the general purpose platform on which you build, train, deploy, and query your own machine learning models. We'll finish up by talking about how to get more information after this session, how to evaluate the opportunities that you have for using Google's machine learning features in your own products. And again, we'll be doing Q&A throughout the session. So let's start with some demos. We're going to switch over to here, and I'm going to show you the capabilities of each of the machine learning vision or each of the machine learning APIs through the simple web interface that you can find online. So we'll start with the Vision API. The Vision API allows you to very easily identify characteristics and content information about pictures. So let's take a look at that. You'll notice here I can select a photo. I'm going to pick a photo off of my hard drive, and we'll drag this into the web browser. Now this is making a machine learning API call to the Vision API, and you can see the whole range of characteristics that this API can give you information about. So it's analyzing the person's face, and it's trying to identify, is the person happy, sad, angry, surprised. And you'll notice there's not a whole lot of positives here. We basically have found he doesn't seem to be super happy, he doesn't seem to be angry, surprised, or whatever. If we look at labels, we can see that it's done a pretty good job of identifying appropriate labels for the photo. So we can see that it's a person. We can see that it's probably a surgeon. I'm not sure where arm comes in, but physician sounds pretty good. You can use this, therefore, to actually go through a range of images, identify the content of the images, and take appropriate actions. I'll show you an application of some of these things in my own demo applications in just a sec. You can get properties. So for instance, this tells you what colors are used in the photo. So if you had an application, for instance, that was going to scan the internet for pictures of your product, and you wanted pictures that had certain color schemes because those would look good in your current marketing campaigns layouts, you could easily do that. Safe Search basically identifies whether or not the content might be inappropriate. So is it adult content? Is it violent? Is it spoof content? This is content where it's sort of sarcastic in nature and might not be appropriate for your applications. And then the JSON here, this is the actual response of all of the characteristics that get returned to you by the Vision API. So what does this all have to do with machine learning? Well, what Google is doing is they are taking tons and tons and tons of images and corresponding labeling information, and they're training a model specifically at identifying the information about faces, labels, properties, inappropriate content, and so forth on images. So this is a very purposeful API, but it's one with wide and common applications. Lots of applications could make use of this, and so they make it available. If we look at the Speech API, again, you have a similar demonstration. Notice the Speech API can work in a variety of languages. I'm going to use English, and I'm just going to speak to the web browser. We need to plan a Q1 business review, and our top priority for Q2 is a proof of concept on the professional edition and an upgrade. You can see that it has actually it's transcribed what I had to say. And this would be super helpful, for instance, if you incorporated this into applications that your customer success managers or your sales rep use. It's hard enough to get those folks to enter good data into your CRM system. This makes it easier. They can just talk into an application, have it transcribe, and automatically add it. Let's look at the Cloud Translation API. So I'm going to switch this from English to Chinese. I can't type Chinese, so it's not going to make a lot of sense. And I'm actually going to choose to translate this into Spanish. Okay, so then if I say, we need to schedule a business review, you'll notice that it translates it on the fly, although I should spell things correctly. Okay, and the primary goal for Q2 is to perform a proof of concept on Pro Edition and arrange an upsell. Now, you'll notice that there are two different translations available. There's the standard edition and the premium edition. The premium edition is intended for larger blocks of text. And rather than doing sort of a word by word or short phrase by short phrase translation, it's looking at the context of the overall document and is able to use large quantities of text and the context in order to make more intelligent decisions about its translation. The fourth API that I'll show you is the Cloud Natural Language API. And what this does is it allows you to enter text and it will analyze the text and sort of draw three different sets of insights. So you'll notice the first is what's called entity extraction. So when it looks at the text, it's able to identify Google is an organization, Android is a consumer good, Sundar is a person, the Consumer Electronics Show is an event, right? So it's able to actually go through and identify entities and then link to information on the internet about those entities. On the other hand, if I said, I really liked Google Hangouts better than anything else, it was clearly as good as Zoom, for instance. You'll notice it's able to extract that Zoom is an organization, Google Hangouts is a consumer good, anything is sort of interesting. So not perfect, but pretty good. Now, in addition to being able to extract entities, which is really useful, for instance, if you want to scan a bunch of tweets about your product and find out what other products are mentioned in the same tweets, that way you get a better idea of what your customers' consideration sets are. You might also want to know how they feel about your product. So we take the same sentence and we have the Natural Language API do sentiment analysis. And you can see that the overall sentiment is positive. So this goes from -1 for really, really negative to +1 for really, really positive. So this is a 0.4, which is good. And this number gives you a strength of the feeling. So it's really good, but you can be sort of, it's really good, but it's not that important. Or it could be really good and it's really important. So you'll notice that the first sentence was a 0.4 and a 0.4, and the second sentence was actually slightly better. Now, if I said it was almost as good as Zoom, and we analyze that, you'll notice continues to be really strong. If you say, I hated this, my video was grainy, and my session kept getting disconnected. Probably because I was hijacking my neighbor's Wi-Fi. Not that anybody would actually do that. Okay, again, if we look at the sentiment, you'll notice overall sentiment is negative, and in fact, the word hate clearly denotes really strong dissatisfaction, also fairly strong overall magnitude of sentiment. The third category of analysis that the Natural Language API performs for you is a syntactical analysis. So this actually does a bunch of stuff that's a little beyond my expertise, but it's able to sort of indicate how the various words are related to one another and what parts of speech each one is, and so forth. So this could be useful, but the first two are the ones that I've seen more typically used within applications by the customers that I work with. So obviously, the functionality is really cool, it's great and all, but you can't really do business by going to each of these special purpose machine learning APIs and working interactively with the UIs. So what you really want to do is you want to have your developers be able to consume these insights from the machine learning APIs within programs. So what we're going to do here is I'm going to shrink this down, and we'll shrink this down. And I've got a couple of examples here, okay? So you'll notice I've got some code in my Finder window. I'm going to actually look at that code in my code editor here. And so the first one that I'm using is the Speech API. So the Speech API, I'm using an example that Google has provided us, and I'm using the Google Cloud Python client libraries. And so what I'm going to do here is in Quick Start, you can see that I'm going to import speech from Google Cloud Library. I'm going to create a speech client. I'm going to open a file, and this is a recorded file that's very much like the content that I spoke into the web page. And I'm going to open the file, read it in as an audio sample, and then I'm going to ask the speech client to actually do a synchronous recognition, extract the content out of the audio file, and transcribe that. So let's see if that works. That's not the one we want. Let's see if this is what we want. That's the image API. So we'll come back to that in a second. So this, let's run it. And if all goes well, we should get output that contains the transcript of the audio file that I recorded earlier. And so you'll see the transcript says we need to schedule and delivering, I didn't speak as clearly as I might have, a Q1 business review. Primary goal in Q2 is to do a proof of concept and close the opportunity for the Pro upgrade. Okay, not bad. Now again, I'm doing this from the command line. I haven't incorporated it into a full app yet, but this shows you how straightforward it is to actually incorporate. So if we go to the Vision API, we have a similar example. So the quick start here basically says, let's import the Vision library instead of the speech library. Let's create a Vision client. Let's find the wake up cat file, and let's feed it to the Vision API and see what information we get back. And specifically, I want to look at the labels. I don't need to see all the other stuff. I just want to see the labels. So let's go back. I'm going to close the speech client. And let's actually open the wake up cat so you can see what the image looks like. There's our cat. And we're going to feed this image to the Vision API and see what it has to say. So it takes a moment or two to run, and it comes back and it gives you the labels. This is similar to the set of labels that were displayed in the web UI during the first example that I gave you. So this identifies the picture as having a cat, the cat being a mammal, the cat having whiskers, the cat being a small to medium-sized cat as opposed to a big cat like a lion or a tiger. This could be a cat-like mammal. So that would be like a lynx or something like that. Something that isn't a cat but looks like a cat. And then animal shelter is the last one. And I'm not sure which components made it look like the animal shelter, perhaps the industrial blinds in the background. But probably lower level of confidence in that prediction. Okay, these are great, again, little code examples, but Jeff, I want to see something meatier. I want to see something actually live and running and show you all of Google's machine learning prowess being brought to bear in a real business problem. Okay, so let's take a look at a live application. This application is a customer success application. It's used by a post-sales customer-facing team to monitor customers' engagement and experiences with the product and to intervene proactively to help drive better outcomes for the customer and better upsell and renewal for the product and so forth. And product at hand is a video conferencing product. People do calls. When they're done with the call, they can leave a rating, but they can also leave a text message, a certain chunk of feedback. And we want to be able to analyze whether or not that feedback is positive or negative. And we want to be able to deal with feedback in a variety of different languages. So what I'm going to do is go to the comments page. And what we have here is a proof of concept. We have a list of comments. These comments are provided in different languages. So you notice the first comment's in English. The second comment is in French. The third comment is in Spanish. The fourth comment is in Chinese. And the fifth comment is in Swahili. So clearly we have customers all around the world. Now, if I were an English-only customer success manager, and I was just looking at the raw feedback provided by customers, I would have no idea what 4/5 of my comments meant. But notice here, I am getting the original comment, and then I'm also getting an English translation. So this is saying it was good. The audio was a bit squeaky. This was saying I was disappointed that there's no support for Linux. Obviously, happy camper with this comment. Another happy camper here. Additionally, not only does this translate from the original language to English, it also performs a sentiment analysis and color codes that, so I can easily take a look. I can see, for instance, that this clearly seems to be a strongly happy customer. This customer is all right. This customer is not at all happy, and so forth. Now, again, this is just a proof of concept. It would be less useful to have an individual looking at this interactively than to be performing, say, a mass analysis where you take all of the comments from all of your users over the last 30 days and you aggregate them looking at sentiment analysis, and that you identify what percentage of comments are strongly negative versus sort of medium versus strongly positive, and you could perform outreach to customers that are strongly positive in order to cultivate champions, whereas you could reach out to unhappy customers to try to do account recovery or solve whatever problem they're running into. Implementing this was just as easy as the quick little demos that I gave you previously. So if I go in and I look here, you can see this is where I put the sample comments. And up at the top, I've imported 2 client libraries. So I've imported the Translate library from the Google Cloud client, and I've imported the language library. And then I make a Translate client and a language client. And then to do the translation, you can see the first thing that I do is detect the language. So I don't know ahead of time what language the comment is in, and I have to tell the translation API what language to translate from and to. So the first thing that I do is I detect that, and then I actually do the translation, and then I'm going to output the translation. Similarly, I use the natural language client to create a document from the text that was provided. Now, you'll notice I'm using the English content. For some languages, you can actually do this with the native language. French, for instance, native detection with the natural language API is not available. So I translated everything into English. And then I do a sentiment analysis. And I'm going to use the sentiment score to output. Now, obviously, there isn't any sort of error handling. You're going to want to, if you were doing production code, it would be more robust. But this gives you a sense that in 10 or 15 lines of code, I am now tapping in to this highly trained, ever-evolving API for language and for translation, and I get the benefits directly in my application with very little real development time. This legitimately took me from the first time I did this took me less than an hour to read the documentation, figure out the APIs, write the code, and start consuming. So, 4 different APIs. We have vision, speech, translation, and natural language. And these all can be very easily incorporated into your applications tomorrow with a small amount of code. So really, you just have to think about what use cases you can leverage. Now, let's say that you need something more specific to your environment. So vision is nice, speech is nice, but let's say you want to do damage assessment. You want to look at images of roofs, and based on the damage to the roof, you want to identify what the cost is going to be to repair that. This is being done by insurance companies now. They actually will fly drones. The drone will go up, fly over, take video footage. That footage gets uploaded to a machine learning model. The machine learning model can then actually do estimates on how long it will take to repair and how much it will cost to repair. In order to do that, obviously, you can't use one of these very general purpose machine learning APIs. You would have to build your own model. I'm not going to demo that because if you actually look, let's do Cloud ML Engine demo. We've got some samples here. So if we did the introductory example for Cloud ML Engine, so this is taking a data set from the census and building a model that will predict based on census demographics what your earnings will be. I just want to show you real quick what's entailed in setting up this model. So you'll notice this article goes on for a little while. It's not actually terribly hard to make this intro work, but it would take significantly longer than we have today to get everything built, to train the models, to test them, and then get them up to speed. A big part of this, beyond what you would see in this introduction, is that you actually have to collect the right data, you have to sanitize the data, you have to format the data. The quality and quantity of your data is really critical. If I were to demo it, what I would probably do is do another demo here, and what you would want to do is actually predict churn. So what customer success teams are really, really interested in is looking at these renewals and finding who's coming up for renewals that you might not get a full renewal on. And that's kind of the holy grail of customer success, is being able to identify potential churn candidates and then intervene in enough time that you can make it go away. Clearly, Google doesn't have a model already created and serving for my particular customer base. I would have to create my own. I would also need a relatively good set of data from a relatively significant number of customers. So since this is a demo app, I don't have all of that at hand, but I think you get the point. So hopefully this has really begun sort of getting you thinking about how you could use either the canned APIs or your own models in your applications. So let's talk a little bit more about the general capabilities of machine learning across Google Cloud Platform. So in the bottom row here, you have the machine learning offerings, and the 4 items on the right you should be quite familiar with, right? There's the Vision API, the Speech API, the Natural Language API, and the Cloud Translation API. Google also just did a Video Insights API where you can actually now extract information similar to what you get out of the Vision API for still images. You can actually do this out of videos now. And then on the left is the Cloud Machine Learning Engine. So it's the Google Cloud Machine Learning Engine, which is quite a mouthful, but it's also quite a handful of technology. Basically, it uses the TensorFlow model development framework, and it automatically provisions and builds the clusters necessary to train your model, and then you can deploy your model and run predictions against the model. The top row here is a bunch of tools used in big data and analytics workloads. And remember, I said that the care and feeding of your data that you feed into your machine learning models is absolutely critical. And so you're going to want to leverage BigQuery, Dataflow, Dataproc, Data Lab in order to collect your data, organize your data, sanitize your data, and get it ready to feed into the Cloud Machine Learning Engine. So a few details about the APIs and about the machine learning engine. So the Cloud Vision API is accessible through a simple REST API. It can detect labels, logos, landmarks, and faces. So an example that we might use in my customer success application is I might want to actually find all of the photos of my product in certain verticals. And so what I want to do is I want to find our logo, but I then also want to get labels that indicate whether it's an industrial environment or a medical environment or a social environment. And that way I can actually extract those photos and put them in collateral aimed at those verticals. It can do OCR, so you can obviously extract the text content out of the images. If you run any sort of a platform where customers are creating and sharing content with other customers, you clearly are concerned about what gets posted because you don't want inappropriate content. This is either violent content or things like nudity to poison the well in your community. So you can actually run all of your stuff through the Google Cloud Vision API before it gets submitted, and you can use this to take appropriate action if inappropriate content happens. And obviously all the image attributes. So again, this is if you want to find all of the files in your giant photo repository that meet certain conditions in terms of color scheme, for instance. The pricing for making use of the Vision API is $1.50 per 1,000 units, and you get an initial allotment of units for free. The second API that we talked about was the Speech API. The Speech API supports recognition of up to 80 plus languages. It can be real-time or recorded. So we showed you real-time when I was speaking into the website, and you can build that functionality fairly easily. Google actually makes a client library. It's optimized to detect the active speaker even when there is surrounding noise. This is really important because very often when somebody's speaking, it's not in an enclosed studio, but rather they may be out on the street, they may be in an open floor plan office, and you want to be able to extract the speech from the primary speaker and ignore the background noise and background conversations. If you are in an environment where you have a lot of technical jargon or words that would not be common in everyday speech, you can you can actually provide word or phrase hints to the API. So you can say, for instance, that gas and energy terminology that isn't in everyday conversation might be common in the audio inputs that you're providing. And so you provide a list of those phrases and words, and it's more likely that they will be recognized. And like the Vision API, it can actually identify inappropriate content and filter that out. Pricing for the Google Cloud Speech API is 0.6 cents per 15 seconds, with the first 60 minutes being free. The Google Cloud Translation API can work with 100 different languages. As I noted in the example that I gave in the customer success application, it can do automatic language detection. The model is being consistently upgraded by Google, so it's constantly getting better. You start with a maximum quota in terms of the number of characters that you can spend, but you can easily adjust this up if you do large amounts of translation. And as I noted, there's a premium edition, and the premium edition is less for translating phrases and short quantities of text, and rather for translating large blocks of text. And it is able to use the context throughout the block to do sort of better narrative translation. Pricing here starts at $20 per million characters translated. The Google Cloud Natural Language API, as we saw, can do sort of three types of insight extraction. It can pull out the entities and identify who those entities are. It can do sentiment analysis, which is the most common use that I've seen in the field, and it can do syntactical analysis. It supports multiple languages. Not all languages of origination are supported. So for instance, French isn't. But you can try it in your own language, and if it doesn't work in the default language that you would prefer, you can actually translate it to English and do that. Pricing starts at $1 per million units, with the first 5,000 units being free. Now, these again are Google's canned models. They're heavily trained, they're really, really strong, but they are general purpose. They don't necessarily solve the problem that you are tackling. So you can build your own models. Now, the way that Google has built their models is they have fed large quantities of data. So an example here would be training the Vision API. You feed it a bunch of images, and with each of these images, you provide an appropriate label. You run a very large, well-crafted data set through a mathematical model, and once you've trained it, what's happening is the machine learning process, in this case running an ML engine, it's going to continue to tweak this mathematical model until it has a very high probability that if you put in a cat, what's going to come out is the label cat. Now, obviously, you probably don't want to replicate the Vision API. You can just pay Google by the image. But what I would do here for, say, the customer success application is instead of images, I would give descriptions of customers. So for every customer of our product, when did they buy? How big a company they are? How much did they buy initially? How much have they used the product? Is usage going up? Is usage going down? And I would give as many features as I think are likely relevant, and then I would indicate whether or not these customers renewed or scaled back their purchases or upsold. And the goal is to create a model that instead of spitting out cat, instead, when I give it a new customer with a bunch of features describing their interactions with our company and product, they give me out a label that indicates high probability of renewal or high probability of churn. To do this, you would use Cloud Machine Learning Engine. You define your models in TensorFlow, which is a machine learning model development framework. This is a portable framework, so you can develop your models and run them on Cloud Machine Learning Engine, but you can also take them and run them on whatever other infrastructure you want. The machine learning engine is tightly integrated with other Google services, so it's easy to pull in data from Google Cloud Storage, for instance, or you could do a bunch of your analysis in BigQuery and dump the results out into your machine learning engine project. They have a feature called hypertuning. So hyperparameters are parameters that are not sort of feature related on individual items, but rather how deep do you want the neural network to be? How many leaves do you want? Hypertune will automatically adjust those parameters for you and find what choices are going to give you the highest level of accuracy in your models. It's quite scalable. So you can go ahead, if you do that demo that I showed you, sort of the example that Google gives you, you start by doing training with a single instance. but you can scale that up and do distributed training. You can train your model using a single instance. You can train your model using 10 instances. You can train your model using 75 instances, and so on. And so this allows you to feed more data into your model training faster. I mentioned that the models are portable, and again, the whole training and deployment and use of your model is a fully managed service. You don't have to worry about acquiring hardware. You don't even have to worry about spinning up individual VMs. You simply turn the dial, say you want to train, and Google will automatically scale out the resources as necessary. Pricing for ML Engine starts at 49 cents per node hour for training and 40 cents per node hour for prediction, plus there's an additional 10 cents per 1,000 predictions charge. Again, if you want to have an idea of the cost that your project may incur ahead of time, go and use the pricing calculator. So, whether it's APIs or building your own models on Cloud ML Engine, you want to think, where can I start using machine learning to make my applications better? And there's tons and tons of applications. I was at Next last week, and as I listened and sat in on the talks about machine learning, I kept thinking of all of the software that I've developed over the last 5 years and all the places that I could use machine learning. So sentiment analysis on comments, churn prediction, upsell prediction, conversion predictions, all tremendous things. So we had done a little bit of data science at my last company where we determined that if a customer got to 1 hour of calls every day for every box that they had purchased, that they would be a customer forever. Their usage kept going up and they would renew. And we found that any customer who didn't hit that milestone would actually churn. And it was very high correlation. So it was fairly good predictability. But with this, it would have been a lot easier. That was a lot of sort of manual work in building processes on local resources. With this, we would be much better off feeding as much data in with a bunch of features and having it build the model for us. So after today's session, as you begin to play with the APIs or you begin to explore building, training, deploying, and using your own models, where do you look for additional information? As always, you start with search. So if you type in Google Cloud and the API name, then you're going to get information about the Vision API or the Translation API. If you type in Google Cloud ML and a topic, then you'll get information about the machine learning capabilities with Cloud ML Engine. So for instance, one of the things that Google does is they support the use of GPUs for training your models using Cloud ML Engine. So if you type in Google Cloud ML GPU, you'll get articles that tell you how to do it, how much it costs, stuff like that. Again, you have sort of the standard organization of documentation for Cloud ML Engine. So you've got the 6 quadrants, you've got a quick start, which that's super quick. That's just basically installing TensorFlow and being able to do something very, very, very basic. Then you have the how-to guides and the tutorials, and this is where you're going to get into that relatively lengthy walkthrough and some other better examples. The documentation for the APIs is a little different than this, but again, if you just search, it'll take you directly to the articles that you're looking for. So that's it for this session. Thanks so much for joining us. I hope you found it interesting and you're inspired to incorporate machine learning capabilities into your own applications. We'll be sending you an email with a link to a code lab, and you can use that to get some hands-on experience with machine learning capabilities on Google Cloud Platform. We'd love your feedback, so feel free to provide feedback through the UI on your screen. And thanks very much.